Welcome Finxters. Today we will be learning how to add two lists element-wise in Python. Now let's try to understand the question with the help of an example. Now let's say that we have been given couple of lists. So these are the two lists that have been given to us. The first list consists of the elements or the numbers 2, 4 and 6, while the second list consists of the numbers 1, 3 and 5. Now our task is to go ahead and add both these lists element-wise. So an element-wise addition means we will be adding the elements which are at the same position in both the lists. So that means 2 is at the first position in the first list. Similarly, 1 is at the first position in the second list. So we will go ahead and add 2 and 1, which will be 3. Similarly, we will go ahead and add 4 and 3, which should be 7. And then we will add 6 and 5, which should be 11. So when we add these two lists, this is the kind of output that we want. 3, 7 and 11 in another list. And this is our output list. So this is exactly what we will be implementing with the help of our code in this video. So let's have a look at the different methods which will help us to perform the element-wise addition of both the lists. So we will begin with the basic approach to solve this question, and that is to simply use a for loop. All we have to do here is we have to iterate over both the lists, which is li_1 and li_2, and then add the elements at the same position in both the lists one by one. Now, if you have a close look at both the lists, then you will find that li_2 has a length which is greater than the length of li_1. In other words, li_2 has more elements than the list li_1. So in this case, the output that we are expecting is 3, 7, and 11. And we will ignore the last element present in li_2. Now, in order to deal with li_2, wherein if you want the output to be something like this, which also takes into account the last element of li_2, which is 15, and then you want to add 0 to it, then the output should look something like this. But we will deal with this condition later on. For now, let's consider that we want to deal with the length of the smaller list. So let's go ahead and find out how we can do that. Let's say that we have a variable li_smaller, which stores the list which has the smaller length. Now we can do this in a single line of code. And to do that, all you have to do is store the list li_1 within li_smaller if the length of li_2 is greater than the length of li_1. Otherwise, that is else, li_smaller will store the list li_2. So that's it. So let's go ahead and break this inline if statement. We are simply storing li_1 within li_smaller if the length of li_2 is greater than the length of li_1. Why so? That is because if this condition is true, then this means that li_1 has a smaller length than li_2. And if this is not true, then we will be storing li_2 within li_smaller. That means that the length of li_2 is either less than li_1 or it is equal to li_1. Hence, we are simply storing li_2 in li_smaller in that case. Now, we need to use for loop such that we will be iterating over the length of the smaller list. So for I in range length of the smaller list, which is stored within li_smaller. Now, let's say that we want to store the output in another resultant list whose name is res. So let's go ahead and initialize res. So there we go. We have initialized res, which is an empty list as of now. And as soon as we move inside the for loop, we are going to append the result of the addition of the two lists. So this is what we are going to do. We will use res.append, and then we will append the output as follows. We will grab each element from li_1 with the help of its index, which is given by I, and then add it to the element of li underscore 2, which is present at the same index. Hence, the element at the ith index in li underscore 2. So this means when we have iterated over all the elements in both the lists and we have computed the sum present in the same index in both the lists, all we need to do is simply go ahead and print res. So that's it. And this should generate the output list which stores the elements 3, 7, and 11. Let's go ahead and execute this piece of code to find out if this works. And there we go. As you can see, that the resultant list stores the elements 3, 7, and 11, and this is the exact output that we needed. So let's try to understand this further. What happens within this loop is that li underscore 1 at the ith index in the first iteration stores the element 2. Then we add it to the element at the ith index in li underscore 2. So this means in the first iteration, we are finding the element at the 0th index in li underscore 2, which is 1. So we simply add 2 plus 1, which gives us 3. Hence, 3 gets appended to the resultant list res. Similarly, in the second iteration, the elements 4 and 3 get appended to this list res, and the result of the addition in this case is 4 plus 3, which is 7. Finally, we add 6 plus 5, which is 11. So this is what happens. 6 plus 5 equal to 11. And then the iteration stops. This is because we are only iterating over the range of the length of the smaller list, which has a length of 3 in this case. So this is how this code works. Now, though this code solves the purpose and gives us the output that we need, however, this is not the most Pythonic solution that you want. Well, before we dive into the most Pythonic solution, let us try to understand how we can optimize this piece of code. Instead of using this entire for loop, you can simply use a list comprehension. So let's say that res is now a list comprehension, which will look something like this. li underscore 1 at the ith index plus li underscore 2 at the ith index for I in range of the length of the smaller list, which is li underscore smaller. Now let's try to understand what's happening in this list comprehension. So this section right here is known as the expression. Within the expression, we are storing the result of addition of the elements which are present at the ith index in both the lists. Now this section right here represents the context which ranges from 0 until the length of the smaller list. In this case, the length of the smaller list is 3. So the value of I will range from 0 until 3 such that 3 will not be included. So I in each iteration will be 0, then it will be 1, and then it will be 2. So this means with the help of this context, we are adding the elements at the 0th index in the first iteration in both the lists. Then we are adding the elements at the first index in both the lists. And then finally, in the last iteration, we are adding the elements at the third index in both the lists, such that we are storing the result of these additions one by one in this list, which is res. Thus, we have the output as 3, 7, and 11 stored within res. Now, let's go ahead and execute this piece of code to find out if this works or not. And there we go. So we have the output 3, 7, and 11, which is exactly what we wanted. Well, now it's time to discuss the most Pythonic solution to our question, and that is to use the zip method along with a list comprehension. Now, before we dive into the solution, let us try to understand what the zip method does. So the zip function is a built-in method in Python which takes an arbitrary number of iterables and aggregates them to a single iterable, that is a zip object. It combines the ith values of each iterable argument into a tuple. Hence, if you pass two iterables, each tuple will contain two values, And if you pass 3 iterables, each tuple will contain 3 values. Well, let's try to understand this with the help of an example. Let's say that we have been given a couple of lists, which is li_1 and li_2. And if you have a close look, then you'll find that these are the same lists that we are using in our example. Now let's say that we will use the zip method upon these lists. So let's say that we have a piece of code which looks something like this, wherein we have a for loop that iterates over the values returned by the zip method that combines the lists li_1 and li_2. So the zip method is working upon couple of iterables in this case, and these iterables in this case are li_1 and li_2. That is, both of these are lists. Now we are simply printing the value of I. That means in each iteration, we are simply printing the output returned by the zip method. So this example is going to help you to understand how the zip method works. So let's execute this piece of code. And there we go. As you can see that the zip method returned 3 tuples, and these 3 tuples consist of a pair of elements. So what are these elements? These are 2, 1, 4, 3, 6, 5. So what is 2 and 1? So if you look closely, you'll find that 2 and 1 represents the first elements in li_1 and li_2. Similarly, the second pair in the second tuple is 4 and 3, and this represents the second elements in the lists li_1 and li_2. Finally, we have 6 and 5 within the third tuple, and this represents the pair which represents the third element in li_1 and the third element in li_2. So this is how the zip method works. It created a pair of elements from both these iterables or from both these lists and stored them in a tuple within each iteration. So each iteration represented a tuple consisting of a pair of elements. Well, all we need to do now is to go ahead and grab both the elements or each pair from each tuple and find their sum and return it as an output. So in order to do that, we will take the help of a list comprehension. So let us understand this with the help of our code. So this was the code that we used. And now the approach that we are going to use is the zip method along with a list comprehension. So as usual, we have the two lists, li_1 and li_2. And now an advantage of this method is that you don't even have to find the length of the smaller list, because that will be taken care of by the zip method itself. Then we need to use a list comprehension, and let's say that the result of the list comprehension will be stored within this variable res. So res is going to be our resultant list. Now, as we learned previously that every list comprehension consists of 2 parts. The first part is the expression and the second part is the context. So let's say that we have the expression x plus y, and now let's try to understand what is x and y. So to understand that, we have to define the context, which is for x comma y in zip li_1 comma li_2. Now let's try to break this and understand how this works. So we are using the zip method upon li_1 and li_2. And we already saw previously that this zip method is going to return a tuple consisting of the pairs belonging to the same index in both the lists. Those elements within the tuple are x and y. And then we are simply grabbing those elements or those items from the tuple, and then we are finding the result of their addition, which is x plus y given in this expression. And then we are storing it in this list res. So let's try to break this down. Previously, we saw that the result of this zip method is going to be something like this. It's going to store the tuples 2 and 1 in the first iteration. Then it's going to store the elements 4, 3 in the second tuple in the second iteration. And finally, it is going to store the pair 6, 5 in the third tuple in the third iteration. So this 2 and 1 represents x and y in the first iteration. In the second iteration, 4 and 3 represents x and y. And in the third iteration, 6 and 5 represents the values of x and y. And then this expression x and y helps us to calculate their sum, which is 2 plus 1, and that will store 3 within our list comprehension. Then we have the elements 4 and 3, which will store 7 within our list comprehension. And finally, it will store the result of 6 plus 5, which is 11 within the list comprehension. Hence, 3, 7, and 11 will be stored in the resultant list. And then we are simply displaying the resultant list, which looks something like this. Now let's go ahead and execute this piece of code to find out if this works or not. And there we go. As you can see that we have the resultant list which stores the elements 3, 7, and 11, which is the sum of the addition of the two lists in an element-wise manner. So this is how you can use the zip method within a list comprehension to solve your problem. Well, now the next solution to our problem is to use the map function and the add function. Well, let's understand what the map method does before we dive into the solution. So map is a built-in function in Python which executes a specified function for each item in an iterable. The item is sent to a function as a parameter. Now let's try to understand this with the help of an example. Let's say that we have this piece of code wherein we have a function by the name myfunc, and it accepts couple of values a and b, and then it returns the addition of, or rather I should say it returns the output by concatenating a and b. Now let's try to understand what are these inputs. So these inputs come from this variable x, which stores the map method. Now the map method in this case has 3 arguments. The first argument is the function itself that we defined previously or above, which is myfunc. So that is the first argument. Then map consists of 2 more arguments, which is this tuple right here. And then we have another tuple, which is this one. So these are the 3 arguments that we are passing within our map method. So what happens here is both these tuples get passed into our function myfunc such that each element at the same position gets concatenated within myfunc. So this means when this tuple gets passed to the function myfunc, along with this tuple, it returns an output wherein the output represents a combination of the items such that apple will be combined with orange, then banana will be combined with lemon, and then cherry will be combined with pineapple. And this entire output will be returned as a map object. In order for us to read the output, we must convert that map object, which is x, into a list. So that is exactly what we have done here. We have converted that map object into a list, and hence we have a readable output. So let's execute this piece of code, and this will make things crystal clear. And there we go. As you can see, the first print statement returns a map object. So this is the map object that we have. And then we have a list which stores the result returned by this map method. So what it does is exactly what I explained previously. It takes apple and orange from tuple 1 and tuple 2, then combines them and returns it as an output in the first case. Then it combines banana and lemon and returns it as an output. So this is what we have as an output. And then it combines cherry and pineapple, hence we have this output. And all of this has been stored within a list. Now this is exactly the concept that we are going to use to solve our question. So let us go ahead and try to understand how we can use this concept to solve the problem. So in this case, we are going to use the map method along with the add function to solve our problem. Now, what you can do is go ahead and define a method which adds the elements of list 1 and list 2. But in order to avoid explicit addition, what you can do is use the operator module. Now, the operator module is a module in Python which consists of several inbuilt functions which help you to compute numerous mathematical operations. And one such function is add, which helps you to add elements from iterables. So let us go ahead and import the operator module. Rather, we should go ahead and from operator, let's simply import the add function. Now we have the two lists as usual, which is li underscore 1 and li underscore 2. And within this variable res, we are going to store our output. So to compute our output, we are going to use the map method, and within map, we are going to pass three arguments. The first argument is going to be the function to which we are going to pass the two lists. So the function to which we are going to pass these lists is add. And now within add, we are going to pass li underscore 1 and li underscore 2. So this will return us a map object. And all we have to do is to now store this entire map object in a list for the purpose of readability. So let's go ahead and execute this piece of code to have a look at the output, and then we will dive deeper into the solution. And there we go. We have the solution which stores the elements 3, 7, and 11 within a list. And this is the exact output that we expected. Now let's try to understand what happens here. Within map, we have the add method. So what happens is the elements from li underscore 1 and li underscore 2, which belong to the same index or the same position, get passed to this add method, and then they get added. So that means 2 and 1 gets added. Similarly, 4 and 3 gets added. And finally, 6 and 5 gets added. So these elements get added in pairs, and then they are returned as an output by this mathematical function, which is add. So that is what add is helping us to do. It is simply adding the elements of the two lists. And this entire operation is getting performed by the map method. Since the output returned by map is a map object, for the purpose of readability, we are explicitly converting it to a list using the list constructor. So this is how you can use the map function and the add function of the operator module to solve this given problem. Until now, all the solutions considered the length of the smaller list. What if you want to add the elements considering the length of the larger list? So let's say that these are the two lists that have been given to us, and then we want to print the resultant list such that it not only adds these values which are at the same index, but if there is an extra element in the larger list or there are extra elements in the larger list, then it will go ahead and add a 0 to that element and then return it as an output. So in this case, let's say that the output that we are expecting is 3, 7, 11, and 15. So in this case, the length of the larger list is taken into consideration. Now, in order to deal with this scenario, you can use iterator module, and from the iterator module, you can use a specific method which goes by the name zip underscore longest. Now, the zip underscore longest method is quite similar to the zip method, but it has an extra advantage which we will be learning pretty soon. So the method or the solution that we are going to use now is zip underscore longest method from the Itertools module. So what zip underscore longest does is it not only helps you to group the elements at the same position in each list, just like the zip method, but it also allows you to take the remaining elements of the longer list into consideration with the help of a parameter known as fill value. So let's try to understand this with the help of our code. Now we will be using the zip underscore longest method. Hence, we first have to import it from the Itertools module. So let's go ahead and do that. From Itertools, let's import zip underscore longest. Okay. Then we have our two lists, which is li underscore 1 and li underscore 2. Now, once again, we will take the help of a list comprehension to store our output. And as we learned previously, that the list comprehension consists of two parts. The first part is the expression, and the second part is the context. For now, let's try to understand the context first, and then we will dive into the expression. So let's say that the context consists of context variable x such that for x in zip underscore longest, and within this, just like the zip method, we will pass li underscore 1 and li underscore 2. Now you might be thinking, what's the difference then? And this is what we will just be learning. We will use another parameter here, which goes by the name fill value. And within fill value, we will pass 0. So what fill value does is, if all the items from the smaller list gets exhausted, so this means in this case, when all the values in the list li underscore 1 get exhausted, then the remaining values will be filled by the value that has been assigned to fill value parameter. So this means that when zip underscore longest works upon li underscore 1 and li underscore 2, it finds that li underscore 2 has 4 elements. However, li underscore 1 has only 3 elements. So what it does is, it goes ahead and fills in the fourth element by the value specified within fill value parameter, which is 0 in this case. So after computation, li underscore 1 will look something like this. So the pairs formed by the zip underscore longest method in this case will be 2 and 1, then it will be 4 and 3, then it will be 6 and 5, and finally it will be 0 and 15. And then all that remains to be done is to add all these elements. Now 2 and 1 is being represented by this variable x. So all you have to do is to go ahead and within the expression of our list comprehension, use the sum method, which is a built-in method in Python, and pass x within this sum. So this will simply pass the values 2 and 1 in the first iteration within sum, and then 2 and 1 will get added and it will be returned as 3. Similarly, 4 and 3 will be passed in the second iteration, 6 and 5 will be passed in the third iteration, and finally in the fourth iteration, 0 and 15 will be passed with the sum method, such that all these pairs or all these values will get added in pairs. And finally, we will have an output which will look something like this. So this is how this piece of code works. Now let's go ahead and let's try to find out if this works or not. And there we go. We have the output as we wanted. So this is how you can deal with the longer list using the zip underscore longest method of the Itertools module. Well, with that, we have almost come to the end of this video. All that remains is another solution, and I purposely kept it for the last bit because this solution will only work if both the lists have the same number of elements. So let's say that both the lists have the same number of elements. That is, let's say both these lists have 3 elements. And now we can simply use the Numpy module to solve this problem. Let's simply go ahead and import Numpy as np. Then we have the lists that have been given to us. Now all you need to do is go ahead and within the resultant variable, you simply have to use the Numpy module and then use its add method. And within add, you have to pass li underscore 1 and li underscore 2. So this line of code will perform element-wise addition of the two lists li underscore 1 and li underscore 2. And finally, you can print rest as an output. So let's go ahead and execute this piece of code and let's find out if this works or not. And there we go. So as you can see that we have an array which stores the elements 3, 7, and 11 as an output. Now let's say that you do not want the output to be in the form of an array. Then what you can do is simply go ahead and convert this array res to a list with the help of the dot toList method. And this will convert the array res to a list. List should be in small case. Okay. Now let's execute this piece of code once again. And there we go. As you can see that now we have an output which represents a list. So this is how you can use the Numpy module to add two lists element wise. With that, we come to the end of this video. I hope this helped you. If you have any doubts, please mention them in the comments below and I'll try my best to answer all your queries. Thank you.